Expert on dynamic systems Todd Rose explores the difference between dynamic systems modeling and traditional conceptual models for education.
It's interesting when you think about change from a dynamic systems perspective, because often when we look more statically at stuff like this, we sort of assume slow linear progression. And in fact, most of our assessments assume that as well. So a kid can be smarter or not as smart as someone else on, again, some linear scale. Like we use IQ, but all the way down to our standardized assessments. And underneath those assessments is this assumption that it's linear and pretty slow. In fact, it's nothing like that. So for example, in dynamic systems, what you first see is some organisms, so we can just say a child, is stable at some level. They perform a certain way, and then something starts to change in the system. So imagine that the child is going through puberty, and you get physical maturation. Well, that's nice, except for all of those muscles and movements and coordination are calibrated finely in the brain with lots and lots of neurons, making you as simple as being able to reach out and grab a bottle of water. Well, if you actually all of a sudden hit a growth spurt, those calibrations don't work anymore. And so it's this huge effort at retuning a system. But one of the things I think is very different about change from dynamic systems compared to our static models is that one of the most important signs you have that a system is changing is increased variability in performance. So imagine that you have some remediation program for a struggling reader. We often make the assumption that the program should have some linear effect. Like by the end, you should see that the child can read at a higher level in a stable way. And we often do this over 2 months. And then when it doesn't work, we say, well, the program must not be effective. But in fact, if you dig deeper into the data and you think about it from a dynamic system standpoint, the first sign that the child is changing is that their behavior, their performance becomes more variable. But this is a problem for things like statistics that treat variability as error, and it actually swamps the signal. And so we assume that the child isn't learning, when in fact they are. And it's a really important sign. So that's just one way, the idea of treating variability as information instead of noise, that dynamic systems is fundamentally different from most conceptual models that we use in education today.